What we're looking at now is the bank corner faster than v equals rg tan theta. That was the velocity when you didn't need any friction to go around that banked corner. Now, I've pre-drawn a little bit of this. This is weight force, straight down. This is the angle the ramp is on. So what I've drawn is I've drawn a bigger support force than we'd normally get. Normally we'd have a support force coming up to where the centripetal force would be horizontal and connecting. So it'd connect, usually it'd connect about there, right? That's not going to happen. We're going to get a bigger one than that. If you're going faster than v, you're going to need some friction, and you're going to need a bigger centripetal force. So the centripetal force is going to be bigger. Now friction can only go in one direction. So because you're driving into the bank faster, the support force gets bigger. And because you need friction, and the friction needs to go in the right direction, you're going to sort of be pushing up the ramp, but we're going to need some friction to push back to hold you in place. But that friction has got to be applied parallel to the ramp surface. So the friction is going to go that way. We don't know how much yet, and we don't know. So we're just working out the formulas. So this vector is your support force. This is your friction. We need to end up having a horizontal centripetal force. That will be our net force. So we know our friction's got to come down to here. So we're just drawing one vector diagram to show it all. We've got three vectors. 1, weight force. 2, support force. And 3, friction. And we end up with our net force, that one, which is equal to our centripetal force, or mv squared over r. Now what I wanted you to do was to come up with that diagram. That's the tough part. That's the part that takes a bit of imagination. And for a challenge, after you've looked at this one, try and do it for a speed slower than v. We're going to need friction again, but it's going to be in the opposite direction, because the car is going to tend to want to come down the ramp. Okay, so how are we going to solve these components? Because what I wanted from you was the support force and the friction. So we wanted Fs and we wanted Ff. Write that down here. Fs and Ff. So now we've got to do a little bit of mathematics. How are we going to do that? Now there's complicated ways of doing that, and there's simple ways. So we've got to have a little think about this diagram and think, how are we going to do it? Now my way of doing this diagram is to split this one. It's going to go right through my words, which is a bit of a pain, but here it goes. What if I do that, and then at the right place, about there, keep it all nice and box-like. That whole thing there now becomes a rectangle with right angles here, and what we had was theta is here, so this theta is going to be here, same angle. Now we're going to try and work out our support force. Now our support force is going to be mg, support force being this one, is mg cos theta. Alright, that's that section, there to there, mg cos theta. Now we've got to do that section from there to there, which is this side of this triangle here. Now we've also got our theta is here, so we can say this side here, which is equal to that side there, is going to be equal to mv squared over r times the sine of theta. So we've made it up of two components, mg cos theta, then mv squared over r times the sine of theta. That's our support force. Our frictional force, this one up here, is going to be equal to mv squared over r cos theta, which is, which one? mv squared over r times the cos of theta gives you this length here, but we've got to subtract this little section off here. So we can write mv squared over r cos theta, mv squared over r cos theta is this length, and now we've got to subtract that little section there, which is going to be minus mg sine theta, and we've got the components. So a tricky little problem. You needed to come up with a diagram in the first place, and then you needed to think up a little bit of geometry to solve the components in the easiest way possible. Like I said, for a challenge, try and do bank corner slower than V.